Good afternoon, and welcome to today's webinar, Iowa's Water Quality and Public Health. My name is Janine Moody, and I serve as the Executive Director of the Iowa Public Health Association. Due to the number of attendees on this webinar, all participant lines will be muted during the presentation. To submit a question for our presenters, please use the Questions feature in your GoToWebinar control panel. I will monitor all submitted questions and pose them to our presenters during the question and answer portion of the webinar. Today's webinar will be recorded and posted along with presenter slides to the IPHA website. Current IPHA members will be able to access the recording by logging into the website. Non-members may register and pay a fee to receive access to the recording via the IPHA events page. A few technical tips for optimizing your webinar experience today. Number 1, utilize a USB headset. Number 2, use a wired connection versus wireless if possible. And number 3, close any applications on your computer which require large bandwidth. IPHA would like to thank the Center for Health Effects of Environmental Contamination, or CHEECH, for its generosity in co-sponsoring today's presentation. CHEECH is a multidisciplinary environmental health research center dedicated to supporting and conducting research to identify, measure, and prevent adverse health outcomes related to exposure to environmental toxins. CHEECH is comprised of faculty and researchers located in the University of Iowa Colleges of Public Health, Engineering, and Liberal Arts and Sciences, and the State Hygienic Laboratory. The roots of public health practice are in addressing environmental causes of disease and originally focused on infectious diseases related to poor water and air quality, unsafe disposal of wastes, and environmental sanitation. The health of our environment is absolutely foundational to everything else that we seek to accomplish in improved public health outcomes in our state and our nation and our world. At their core, health issues related to environmental exposures are issues of health equity, because not all Iowans are equally protected from related adverse health outcomes. Water has a profound influence on health. A minimum amount is required for consumption each day for survival, but the influence of water on health goes far beyond this, as water is a principal medium for disease prevention. Iowa's water quality issues are complex and severe, but for the health of Iowans, our solutions must be collective. We must promote the basic right of all Iowans to safe and affordable drinking water. Public health is grounded in science, and so it is imperative that we speak from an evidence-based, research-driven perspective. This brings us to the intent of today's session to increase awareness of the body of research on the public health impacts of Iowa's water quality. Now let's meet today's presenters. Dr. Peter Weyer is the Interim Director of the Center for Health Effects of Environmental Contamination at the University of Iowa. He also holds academic appointments in the U of I College of Public Health and College of Liberal Arts and Sciences. His primary research interests are environmental epidemiology, water contaminants and chronic health effects, and environmental policy. Joining Dr. Weyer will be Ann Robinson. Ann Y. Robinson is Agricultural Policy Specialist for the Iowa Environmental Council. She has a background in policy and communications, working for nonprofits, for the Iowa Department of Agriculture and Land Stewardship, and for Cooperative Extension. She has degrees from the University of Missouri-Columbia and University of Wisconsin-Madison, where she was a Science Writing Fellow for the University Industry Research. Ann hails from her family's Century Farm in Missouri. I'll now turn the presentation over to Dr. Weyer. Okay, Dr. Weyer?
Yes.
Okay.
Okay. Well, thank you very much, Janine, for the nice introduction. It's really talk about Iowa's water quality and public health. Now, recently, really over the last couple of years, there's been a huge debate on water quality in Iowa, and a lot of the discussion has centered on what is the problem, where does it come from, how do we fix it, and how do we pay for it? Today, I'm going to be talking about a public health perspective on water quality. We all need clean water to drink and for recreational purposes, and I think focusing on public health and how water impacts our lives and our health is really important to the discussion that's going on in the state. So I'm going to start off with talking about some long-standing issues, things like nitrate, which is kind of driving the discussion in Iowa right now. Talk about some of the pesticides that we see in our water, disinfection byproducts that we get from treating the water to make it safe to drink. I'll also talk about some emerging issues, things like arsenic, some of the Cyanobacteria. Microcystin is a problem in recreational waters and surface waters, and it's also becoming a problem for drinking water sources. Talk a little bit about a new class of insecticides that are being used in the state that we're seeing in some of our water sources, and also talk a little bit about some pharmaceutical compounds and personal care products that are showing up in some of the surveillance activities that are going on. So what I'll do is I'll focus mainly on drinking water exposures and talk about some research going on there, but also touch briefly on recreational water use. So when we do research on drinking water and health, and that's what we do here at CHEEK, the center's main research focus is on water contaminants and health. What we do is there are some questions we like to think about and to try to answer and to work through when we're doing this research. One of the first things we ask is there biological plausibility related to the contaminant we're looking at with respect to human health? In other words, what is going on in the body? Let's say if we ingest compound A, what happens to compound A in the body that makes it problematic for our health? And I'll talk a little bit about that. We need to know about what are the other risk factors for a specific health outcome. For example, in cancer research, we need to know about the genetics of the person that we're looking at, the lifestyle, the diet, what do you eat? Do you have a high-fat diet? Do you drink alcohol? Do you smoke? Do you get enough exercise? What are your occupational exposures? How might they be involved in increasing risk for a certain health outcome? When we're looking at drinking water, we like to know, if possible, how much water a person consumes in a day. How many glasses of water per day? Do you use water to mix your coffee, your frozen juice concentrate, that type of thing? We also need to know, or would like to know, how much you drink at home and how much you drink at work, how much you drink at school, etc. A lot of times we're not able to get that information, and I'll talk about that in just a few minutes. And finally, in these health studies, when we do get a positive result, we like to see that research corroborated by other research so we know that what we're doing is on the right track. So, drinking water health studies in Iowa, and particularly at the University of Iowa, we have a lot of good resources to conduct this research, and I'll talk a little bit just for a second about how that happens. In the College of Public Health, there are health registries, information on outcomes like cancer and birth defects. And what these registries are, they're data sources that have information on every cancer diagnosed in the state of Iowa, information that goes back to 1973 through the current year, information on every cancer diagnosed, the stage of disease, the survival, treatment, all kinds of information that is helpful to us when we do this research. Also in the College of Public Health is a birth defects registry that has similar information on every birth defect diagnosed in an infant, but going back through the early 1980s. So what we do is we have that health outcome information. There's lots of information from special studies that I'll also tell you a little bit about, collecting information on lifestyle factors of the people that have the disease or the moms of the kids that have the birth defect. So we can look at that information and analyze all that in terms of what might be important with respect to risk. At Cheek, we also have water databases. We have information on all the Iowa public water systems in the state. And we also have information on private drinking water wells, a small set, probably about maybe 1,400, 1,500 private wells. We have lots of good information on water quality in those private wells. We also have a really good network of collaborative relationships, State Hygienic Lab, the College of Public Health, and around the state, the county health departments, state agencies like IDPH and IDNR, the funding agencies at NIH, CDC, and U.S. Geological Survey. The Iowa Drinking Water Utilities play a key role in doing this research. And of course, the people of Iowa are just really good in terms of getting involved in the research. They're always very helpful and willing to help us do these types of studies. So I'd like to take just a minute and talk about nitrate. And nitrate is, like I say, it's kind of what's driving the discussion right now in the state. And what I'll do is I'll tell you about some of the research that we've done on nitrate in drinking water and why we think it is a problem with respect to public health. This slide you see in front of you here is the biological plausibility slide for nitrate and cancer. And in a nutshell, what happens is when you ingest nitrate from drinking water or in the diet, and also nitrite in the diet from vegetables, processed meats, those types of things, in the oral cavity, that nitrate is reduced to nitrite by bacteria. It is then ingested into the gut where it undergoes further reduction by amines and amides. The nitrite is reduced to what are called nitrogen nitroso compounds, or NOCs. Now, these things are catalyzed or enhanced by things like red meat and inhibited by antioxidants like vitamin C. Well, why are these nitrogen nitroso compounds of interest with respect to human health? Well, we see in laboratory animal studies that of about 300 NOCs tested, 90% of them were carcinogenic or cancer-causing. They were cancer-causing in 39 animal species, including 6 species of primates. And the tumors that were developed in the animal studies are listed here, things like lung, thyroid, bladder, kidney, ovary. So this gives us a good indication that nitrogen nitroso compounds, or NOCs, we need to look at them, if possible, epidemiologically. And because nitrate is involved in the reduction to NOCs in the body, sources of nitrate for humans, including drinking water, are something that we're very interested in. So I'm going to talk about one of the studies that we did in Iowa. This is the Iowa Women's Health Study. The study started in 1986. It was a National Cancer Institute funded study. And what it was a study of postmenopausal women, of their lifestyle and health outcomes. It was a prospective cohort study, meaning that we enrolled the people at a certain amount of time, and then we followed them forward through time. So every couple or 3 years, we go back to the people, ask them further questions and things, and track their health from the time they were enrolled into the future. We had information on source of water for these people. Over 22,000 women we found out of a cohort of about 45,000 were on the same water source for more than 20 years. Iowans don't move a whole lot. And so this is really great for this type of research where we know what their water supply was and that they were on it for these long periods of time. At Cheek, we had nitrate data from 1955 to 88 for municipal supplies. And so even though we didn't have information on nitrate in the home or at the tap where these people were drinking the water, these women were drinking the water, we did have municipal level nitrate information that we were able to use, and we averaged that over a 33-year period. And this is important because cancer generally has a latency factor. It's not what you're exposed to right now, it's what you were exposed to in the past. So we were able to go back about 30 years to see what kind of nitrate exposure these women had. We had information on nitrate in the diet, their vitamin use, smoking, that type of thing. We were able to follow these people through the Iowa Cancer Registry, which I spoke about a couple of minutes ago, since 1988 to the current time. And here's some of the results we got looking at nitrate in drinking water and cancer risk. For bladder cancer, we found an almost threefold risk at 2.5 milligrams per liter nitrate nitrogen, and the drinking water standard is 10 for women who are on that water supply for greater than 20 years. A later follow-up of the same cohort, meaning there were more cancer cases that came by linking to the registry over time, we found that there was a 1.6-fold increased risk at half the MCL for ingesting that water for more than 4 years. In the same study, we looked at ovarian cancer. We found an almost twofold risk at about 2.8 milligrams per liter for women on the supply for more than 20 years. And again, later on in follow-up, we found the same increased risk, twofold risk, at over 3 milligrams per liter for over 11 years. So we're looking at this, and we see that, it's not, excuse me, I had to take a drink there. It's not the blue baby syndrome is kind of driving the discussion on nitrate in the non-scientific circles. And we're seeing that cancer really is something that we're concerned about. We haven't seen a case of blue baby syndrome in Iowa since the 1970s. So cancer looks like it might be something that we should be concerned about with respect to nitrate. The last bullet on this slide is for thyroid cancer. And we see that there again, the biological plausibility is listed under the first dash as to how nitrate works in the thyroid. You see that it decreases the uptake of iodide, which decreases the level of a couple of hormones, which leads to an increase in thyroid stimulating hormone, which leads to changes in the cells, including neoplasia, which leads to cancer. So that research found a 2.6 increased risk for thyroid cancer at 5 milligrams per liter nitrate nitrogen for over 5 years. There are also studies, and in epidemiology, we have positive studies and we have negative studies. There have also been studies conducted in Iowa that have found no increased risk of cancer with nitrate, and they're listed here. A study that was conducted in the late 80s found no increased risk of colorectal cancer, bladder cancer, brain cancer, or pancreatic cancer. Now, the additional research that's ongoing, we're trying to look at mixtures. When you see your and those of you that work with water, source water net, you know that there's not just one contaminant in the water. When we're looking at information about drinking water, there may be a little nitrate, there may be a little atrazine, there may be a little of this, there may be a little of that. And we're trying to look at those mixtures to see what might be important with respect to risk. So that's ongoing research. So let's move to birth defects. Here again, another study. This is a case control study where you enroll women who have babies with certain birth defects, and then you match a control based on age, race, and other factors to that woman. And this is the National Birth Defects Prevention Study, which was a CDC-funded project in 10 sites across the U.S., including Iowa, Texas, North Carolina, New York, Massachusetts, Utah, Georgia, Arkansas, and California. And we were looking at nitrate in drinking water, in the diet, and also in drugs. Now, Iowa and Texas have statewide nitrate data, so Iowa and Texas were involved in a study of nitrate in drinking water and risk for birth defects. As part of this study, we also tested bottled water in both states. We sent some graduate students out to collect bottled water samples in convenience stores and grocery stores around the state, and all those samples were tested at the State Hygienic Laboratory and included in the analysis. Now, as I said with the cancer research, the exposure goes back decades. For birth defects, we're interested in a very tight time frame for exposure. With this study, we were interested in 1 month preconception through the first trimester for nitrate in the drinking water. So we're calling that the B1, P3 period, 1 month before conception through the first 3 months of pregnancy. And we linked the mom's residence during that time frame to the public water supply data that we had. We also had water consumption data for this. We had information on water filter use in the home. So what did we find in this study? This was published in 2013. We found that moms of babies with spina bifida were twice as likely to ingest at least 5 milligrams nitrate daily from their drinking water than control moms. We also found that moms of babies that had limb deficiencies were 1.8 times as likely to ingest about 5.5 milligrams of nitrate daily from their water source. And moms of babies with cleft palate were not quite 2 times as likely to ingest almost 5.5 milligrams nitrate daily from the water. So this was an eye-opener for us and for the public health community that nitrate from drinking water and also from the drugs. The diet information did not really show any connection with birth defects, but that nitrate is also related in these studies to birth defects. Other studies on drinking water nitrate reported positive association with neural tube defects like spina bifida. And you can see there was a Canadian study, a California study, and another Texas study that reported those associations. So now I'm going to move to a very common exposure in drinking water, especially in surface water sources, drinking water utilities that use surface water, water disinfection byproducts. We disinfect water to protect against bacteria and viruses and that type of thing in the natural or organic matter. It's much more of a problem in surface water. They have higher loads, organic loads than groundwater. But groundwater is also disinfected to a lesser extent than surface water, but also disinfected. So the compounds that we are able to look at based on surveillance through the Safe Drinking Water Act are trihalomethanes and haloacetic acid. These compounds are carcinogenic and teratogenic, meaning they cause birth defects in some animal studies. The epidemiologic studies I'll show you show some increased risk of cancer associated with chlorinated surface water. Now, the drinking water standard for total trihalomethanes is 80 parts per billion, and for haloacetic acids, the 5 haloacetic acids combined is 60 parts per billion. That's on an annual average. Let's see. That's based on an annual average of quarterly samples at a distribution plant or a treatment plant. So some of the results we have from disinfection byproduct studies and health, these studies are in Iowa. Mike Kramer in 1992 looked at small Iowa towns in a reproductive health study, and he found a not quite 2-fold risk of intrauterine growth retardation, which is low weight for gestational age, with chloroform in the water at over 10 parts per billion. Another study by Ken Cantor at the National Cancer Institute in the late 90s found an increased risk for bladder and rectal cancers with longer duration on a chlorinated surface water source. Now again, being epidemiology in the Iowa Women's Health Study, which I've already talked about, we found no association of trihalomethanes with either bladder cancer or ovarian cancer. Okay, we're going to move right along here and talk a little bit about atrazine. Atrazine, as you guys all know, is a heavily used herbicide. And this map is from U.S. Geological Survey and shows atrazine use in the United States, and I think, not sure, this is a fairly recent year, maybe 2-3 years ago. The map doesn't change all that much. And you can see in the central Midwest part of the country, the Corn Belt, the red area indicates that the average annual use is over 34.5 pounds per square mile. Okay, so lots and lots of atrazine used in Iowa, Illinois, Indiana, in the corn growing area. Again, atrazine is a common use herbicide. The information from the National Ag Statistics Service for 2014 showed that about 7.8 million Iowa corn acres had atrazine applied at a total of 6.7 million pounds across those acres. About 8% of the private well water samples we see have detectable atrazine, and about 11% have the atrazine metabolite, desethylatrazine. About the same amount of public water supplies have detectable atrazine in the finished water. Now, the EPA drinking water standard is 3 parts per billion, and atrazine is listed as a possible human carcinogen. That MCL, the 3 parts per billion, was set in 1991. So some of the studies we've done looking at atrazine in drinking water and health, and again, these are Iowa studies conducted in Iowa. In the Iowa Women's Health Study, Maki Inouye Choi found no association with atrazine and ovarian cancer risk. In a earlier study in southern Iowa, Ron Munger at the College of Public Health looked at Rathbun communities at a higher risk of intrauterine growth retardation, which we talked about a minute ago, associated with the triazine herbicides, atrazine, and cyanazine. And again, with the National Birth Defects Prevention Study, we did not see any association of atrazine and risk for hypospadias. Okay, some emerging issues. Just to touch a little bit on some of the things. And arsenic is an interesting compound to study. It's naturally occurring. It's not something that you can say it's because of this group or that group or this land use or that land use. It occurs naturally in the geology. It gets into the groundwater because of certain geologic conditions and subsurface chemistry, as well as well use. The drinking water standard is 10 parts per billion in public water systems. That began in 2006. Prior to that time, the drinking water standard was 50. And the health concerns we know from exposure, and the cancers you see listed here are from studies that were done in Southeast Asia, where they have Bangladesh and some places, other places, where they have huge concentrations of arsenic in their drinking water, you know, the 400 to 500 part per billion level. So we luckily don't see that kind of concentration here, but some of the things that have been looked at and may be related to arsenic in drinking water include cardiovascular disease and some cognitive and immune effects. So we've done quite a bit of surveillance on arsenic in private drinking water wells. Back in 2002, 2003, there was a study that was conducted by probably everybody on this webinar today was involved in this and in the swirl phase 2, because lots and lots of different agencies at the UI, IDNR, IDPH, USGS, county sanitarians across the state and so on were all involved in these studies. In the 2002-2003 study, we found 23% of the wells we tested had detectable arsenic. About 5 had high arsenic at over 10, and we had found a maximum concentration of 130 parts per billion. In the Iowa statewide rural well water survey in 2006-08, we sampled almost 475 wells, and we found that almost half had detectable arsenic. About 8% had arsenic over 10, and we had found a max concentration of 75 parts per billion. We also found that there were high concentrations of arsenic in the private wells in 31 different counties in that 2006 to 2008 study. So all this surveillance and research led to some policy changes at the state level. There were a number of conferences and educational outreach things going on. And one of the really, really great things that came out of the work on arsenic, it's a public health success story in my mind. The Grants to Counties program included arsenic testing effective July 1, 2015. Prior to that time, it was just nitrate and bacteria, and now private well owners can get their wells tested for arsenic at no charge. And another success story, one of the really high-profile, just wonderful project carried out by the Cerro Gordo County of Public Health Department in Cerro Gordo County, was the arsenic testing that they did up there. One of the things they did was they really got the word out to the community. Here you see a billboard that says get your well tested. Arsenic, get your well tested. Get a hold of Cerro Gordo County Health Department. And they also sent out postcards to all the private well owners in the county, telling them to get their well tested for arsenic. Just a really, really super outreach program that was just a great project. Okay, moving on to another emerging contaminant. Harmful algal blooms, blue-green algae. We know that phosphorus mainly, and to a lesser degree nitrogen loading of lakes, reservoirs, and rivers can result in these algal blooms, depending on other factors, heat, and that type of thing. Cyanotoxins, it's estimated that 25 to 75% of the blooms are toxic. The most common toxins are listed here. Microcystin is the one we're most familiar with. And the potential health impacts include stomach or liver illness, respiratory problems, and neurologic effects. It's also an emerging issue. It's mainly, in Iowa right now, we're looking mainly at recreational water use, but it's also an emerging drinking water issue. For example, the Des Moines Water Works recently had an alert about microcystin in the Raccoon River that they had to deal with when treating the water. Recreational water exposures, we did a study in Johnson County in summer of 2005 called the Iowa Beach Study. We enrolled, actually we talked to about 1,000 beachgoers at Coralville Reservoir in Lake McBride. About 260 of them followed up online over time with self-reported GI illness and skin irritation, rash types of things. We took composite water samples daily, looking at Enterococci, E. coli, and microcystin, and we found positive correlation between microcystin and skin rash. So we know that this is a bad actor for recreational water use. Again, it's an emerging issue for drinking water. The Toledo, Ohio problem with microcystin demonstrates that it can be a major, major headache with respect to drinking water. Another emerging issue, a new class of insecticides, the Neonicotinoid Insecticides, are replacing the organophosphate and carbamate. Insecticides are used a lot as seed coatings. They have adverse ecologic effects. Some immune suppression in insects can affect pollinators like bees. So the bee problems we're seeing may be related to some of these insecticides. It's highly water soluble, and a USGS survey in Iowa in 2013 detected these neonicotinoids in all 9 sampling sites in Iowa. So the last emerging issue I'll talk about just a little bit about are pharmaceuticals and also personal care products in water. The problem with pharmaceuticals is when you dispose of them incorrectly, you put them down the drain, you flush them down the toilet, they go to the wastewater treatment plant and are probably not removed through the treatment processes at your wastewater treatment plant. The wastewater plant effluent goes to the river and still has the compounds in it. So if there's a drinking water plant downstream that also uses that surface water supply, and the intake is bringing those compounds into the drinking water plant, the question is, are they removed through the drinking water process, or does it get into the finished water and you're exposed through your tap, which this cartoon shows just very well, possibly to very low trace levels of some of these pharmaceuticals. So surveillance activities, DNR and USGS are doing surface water monitoring and some groundwater monitoring. Compounds are commonly found. These compounds are commonly found in U.S. rivers and streams. And as I said, conventional drinking water treatment may not completely remove all these compounds. EPA's current strategy is to improve the science and public understanding, identify partners, and take regulatory action down the road if they think that is necessary. So with that, I'm going to just say thank you to all the collaborators that have been involved in this drinking water research. Again, we think it's a lot of things going on with drinking water and contaminants that we are looking at and will be looking at. The public health concern in terms of water quality in Iowa, we think it should be a main driver in the discussion that's going on at the state level now with respect to water quality. And with that, I think I'll close. Thank you.
Thank you, Dr. Wire. I know we've got some questions coming in, so I just want to use this break as an opportunity to remind people, if you look at your GoToWebinar control panel, that little gray screen that should be on one side or the other of your monitor, please use the questions feature to submit questions, and then we'll be compiling those and handling them all together during the Q&A. And now I will go ahead and turn the presentation over to Ann Robinson with the Iowa Environmental Council. Ann?
Yes, thank you very much. Can you hear me all right?
Yes, we can hear you and we can see your screen.
Oh, good, good. Thank you for the opportunity to present today. I have to say that it's an honor to present with Dr. Peter Wire. I've long been appreciative of the work of the Center for Health Effects of Environmental Contamination. And this year, as I embarked on this research project that I'll be talking about, I had a better even appreciation of its importance nationally and internationally, really. And also think we're lucky to have the work of Iowa Public Health Association in this state. So for those of you who may not be familiar with the Iowa Environmental Council, I wanted to just briefly let you know that we are an alliance of over 70 diverse organizations and businesses and hundreds of individual members. We are a nonprofit, and we attempt to provide an amplified voice for Iowa's environmental organizations, trying to be balanced, science and information-based as we advocate for a cleaner, healthier Iowa at the legislature, in rulemaking with agencies, and even in some cases where necessary in the courts. So I'm going to really just briefly today to make sure that you're aware of a white paper that we have that goes into some more detail on studies that Peter elaborated on earlier, and that I think it's kind of a primer on some of this information that has some useful background information for people. We did this paper, Nitrate in Drinking Water, a Public Health Concern for All Iowans, this year when we were inspired by going to a number of meetings, more and more meetings, where the questions were being asked basically, is our drinking water standard for nitrate too stringent? When was the last time you heard of a blue baby? Maybe we don't really need to worry so much about nitrates in our drinking water, which was a worrisome question, but is also a fair question really to ask. Perhaps the threat based on methaglobinemia might be, if we were just really needing to address that, if that was our only issue, maybe it would make sense to raise the drinking water standard, which is something that would have to be done federally. That's not a state-based policy. So we wanted to understand. We started to research and ask questions of health experts. We'd heard vague information that there were other health issues related to nitrates and nutrients in our drinking water. We did decide to focus on nutrients because that in itself is a complicated enough question. It's very hard to study. So the researchers who are doing this work had their challenges cut out for them. They have to sort out many influences, as Pete has talked about. And in some cases, the synergistic effects may exacerbate outcomes, such as with pesticides or bacteria. People also have different responses. And also depending on, for example, if people are taking high doses of vitamins that have good things in them, that may, change the results that they're seeing if they're taking folic acid and vitamin C, for example. Also, the nitrogen cycle is very complex, and Peter talked about how nitrate itself may not really be the culprit, but as soon as you take it into the body, it starts becoming other things that are more problematic. Clearly, there needs to be more research. That's usually always the case, but I think this is even maybe more of a concern and more compelling as we are facing greater exposures to nitrate and some of these other compounds that come from a variety of sources, especially agriculture, because that dominates the landscape of Iowa, but also wastewater treatment plants, urban sources from even our own lawns, and other things that we are exposing ourselves to, such as cigarette smoking. So I embarked on an extensive literature review, basically, is what our white paper is based on, looking at the research linking nitrate to many health concerns in human and animal studies. Many possible concerns were represented by limited studies, as far as we could tell, and sometimes even the findings conflicted, as Peter highlighted. So our paper, really, we ended up deciding to focus on those that we felt were the most widely supported based on multiple studies, often over many years. We focus on birth defects, bladder cancer, and thyroid cancer. And we highlight research that's been done here in Iowa, much of it that Cheek has been involved with or been a leader on, but also looking at studies around the country, beyond that, and around the world. Well, you can read our study, and I'll give you a link to it in a minute. We have just a 2-page executive summary, and the full white paper is 11 pages with a lot of references. But in my short time, I want to remind us that put this in context. There are other problems too with nitrate nutrient pollution, generally including the Gulf hypoxic zone, which is really what led to our Iowa nutrient reduction strategy. Also, as Pete alluded to, the impacts on our public lakes and toxic algae blooms, microcystin, and drinking water supplies that are facing potentially being contaminated by microcystins, which could have significant toxicity problems. And also, we need to remember that these are also harmful to aquatic organisms, that natural levels were much lower than what we are experiencing today in many public water supplies. And so, there are other issues for the environment and biological organisms. And it's not like this is a hopeless problem. We can do better, and we can make progress. So there are opportunities ahead. We need sustainable funding. We believe that this is a good chance that this year we might get our Iowa Natural Resources and Outdoor Recreation Trust Fund supported in one way or another, or other sources of funding could be coming on board that can really help us address these issues. The nutrient reduction strategy that we have in Iowa is an important tool, and we are starting to see a more integrated watershed approach at our state level, which would be very positive for many reasons. And then I just want to remind us too that we have influence as consumers that really is an important driver in the marketplace for trying to get practices out on the land that can better protect our water supplies. And we can purchase, for example, one possibility is to purchase certified organic products, and that certified organic label, people that earn that label, which is not perfect necessarily, but is one of our only third-party verified programs, have to meet a number of environmental regulations, and that will be good for our water and our land in a variety of ways. Cleaner water is going to bring multiple benefits, and so by spending the money, taking the time and effort to address our public drinking water, in many cases we're also achieving multiple benefits of reducing potential for flooding, strengthening local economies, providing more inviting places to recreate, and trying to make our communities just better places in general. So if you would be interested in finding out more about what our paper says, you can find it at our website. I think this is kind of a long URL, but it's a link from our front page too. And I want to say thank you very much to a number of reviewers that really helped us as we were researching and asking questions, trying to make sure that our paper was credible and science-based. We incorporated many comments, and by people who are willing to be acknowledged. On page 8 of our paper, you can see some of those folks, but then there were also health experts and other technical reviewers that helped us who felt that they really preferred not to be acknowledged. But we still want to thank them. They gave us their time and effort, and this is a very controversial topic. So, that was one thing that was kind of interesting about doing this work this year. If you have questions or comments that you want to send to me, here's my email. And if you have any trouble, accessing a report, for example, we'd love to hear from you if you have additional questions or stories that you would think would be relevant. Thank you. That's all for now.
Great. Thank you, Anne. We appreciate your time and sharing a recap of the work that you've been doing and the products that you've been creating. So I will now bring Dr. Wire back with us. Pete, can we just do a sound check, please?
Yeah, I'm here.
Okay, great. We will now move into the Q&A portion of our webinar. So just a reminder to go to the GoToWebinar control panel and use that feature to submit your questions. We have a few queued up here, so I'll begin with those, but we do have several minutes remaining, so please feel free to keep them coming. So the first question is, I think, to you, Pete. Were the studies on birth defects and nitrates based on municipality water sources, private wells, or a mix?
The birth defects research that was done in Iowa was on public water supplies, municipal wells. In Texas, they included municipal water supplies and also did a separate study on private water supplies that we were not able to do here. So overall, it's a mix, but in Iowa, strictly municipal water sources.
Okay, thanks. The person who submitted that question, if you have a follow-up question related to that, please go ahead and get that in. And then, let's see, another question for you. Dr. Wire, cyanotoxins resulting from nutrient-rich waterways are becoming an increasing problem for drinking water utilities, and they are difficult to treat. Is CHEEK planning to do more research in the near future on blue-green algae effects in Iowa?
Not in the immediate future. We have done some work in funding projects. We have a seed grant program that provided some grant support to researchers at Iowa State who are looking at harmful algal blooms. We are not planning at this time to do any kind of drinking water research related to microcystin.
Okay, thank you. The next question, Anne, is for you. Kudos to the Iowa Environmental Council for taking a positive step forward in protecting the health of Iowans by releasing the white paper. As a policy organization, what strategies does IEC have in mind to counteract those who deny the health effects of nitrate in drinking water and continue to be an advocate for Iowans?
Well, thanks for the question. Yeah, I think that really is a question for all of us as we move forward together. And I guess I alluded to some of the things that we think are policy options in the near term, that where we can work together and individually. One of the things I would mention is that there are upcoming opportunities to educate others and ourselves maybe more on these topics, including at the Governor's Public Health Conference coming up in the spring. And I know Dr. Wire is planning to do some more speaking on this. We are as well. I think part of it is getting the word out and emphasizing that this is a concern for all Iowans. One thing we really try to do in the report is remind people this isn't just about Des Moines drinking water. This is about our drinking water for everywhere. Maybe not all public water supplies are faced with these problems, but many are, and many of them may not have many millions of dollars that they can spend on advanced treatment. And then there are private wells, people who consume water from private wells that may be at greater risk because those wells, the water from those wells is not regularly tested or not required to be tested. And frankly, one thing I'm doing is I think that we can enlist some interesting, partners in this, including it's wonderful to see that the public health community at the local level is starting to get engaged, and I think that local level is really a place to emphasize, and including a meeting with our officials at every level to make sure they're aware of these issues and possibilities for addressing them.
Okay, thank you, Anne. The next question is, speaking of local public health community, comes just from there, and it says, what is the connection between CAFOs and nitrates? How should we best advocate for safe drinking water when also balancing the need for jobs in our agriculturally strong economy?
Pete, do you want to take that first?
Sure, I'll jump in. Sources of nitrate contamination are many. It's problems with agricultural runoff, urban areas, to a lesser extent, overuse of nitrogen fertilizers on lawns, golf courses, that type of thing, municipal wastewater plants, livestock facilities. There's just a myriad of sources with respect to nitrate. I think depending on the land use in a particular area, that is where you really need to focus on what's going on in that so many square miles or county or whatever it is as to what the problems might be. So I think it's a problem that we could all speak to and we're all involved in terms of being sources of nitrate in the environment. And as far as the second part of the question goes, I'll pass that to Anne.
I can't remember for sure what the second part of the question is.
I'll repeat that, Anne. So it's how should we best advocate for safe drinking water when also balancing the need for jobs in our agriculturally strong economy?
Oh, right. Yeah. Definitely a good question. But many of these things that we can do, I think, are not going to threaten jobs nearly as much as the low prices maybe for corn and soybeans are already doing. That many of the opportunities for doing a better job on the landscape, some of them come with, could be better for economy on the farm, and could bring new people into the job market locally and at the state level. So it's complicated and it depends a lot on a lot of different things, but I think it shouldn't really be posed as either or.
Okay, thank you. Okay, another question specifically to you, Anne. Will the Iowa Environmental Council have any legislative asks of lawmakers on the water quality front?
Well, we certainly will. We already know that one of our most important asks is going to be additional sustainable dedicated funding for water quality. We hope that that will come in the form of supporting the trust fund that was already widely supported by Iowans and has a formula that we believe can bring multiple benefits. But we are working on developing, our policy recommendations for the coming legislative session. So thank you for asking that question. Stay tuned. We'll have more for you that you can find on our website, or you can stay in communication with me, and I will love to share those with you.
Okay, thank you. And then this would be my last call for questions. We have one more in the queue. If anybody else has another question, now's the time to get that submitted. And here, let's see, this last question that I'm seeing at present is there a mitigation for arsenic in well water?
Arsenic, you can remove or reduce arsenic at the tap or at the coming into the home. Whole house filtration units or point of use at the tap can be installed. They're fairly expensive. My understanding is that to put one under the sink, it's a reverse osmosis with some kind of an iron filtration mechanism included. It could run you somewhere between $300 and $500 to install. A whole house filtration unit might run you $2,500 to $3,000. So it's fairly expensive to do that. The problem with arsenic out in the rural areas is that it seems to be very random in many places as to where it's a problem. For example, in the 2006 to 2008 study, we had some counties where we might find a very high arsenic concentration in a well, and just a few miles away in another private well, there was no arsenic. And so it seems to be, while it's based on the geology and things going on in the subsurface, it was fairly random in terms of where it showed up around the state. So, with public water supplies, they're required by the Safe Drinking Water Act. The MCL is 10. They have to get it below 10. 10 is still high, but it's legally the water is safe to drink at below 10. Out in the private well community, that's something that is up to the well owner to deal with, which is why it's a really good idea to get your water tested through the Grants to Counties program and have it tested for arsenic. If you have a problem with arsenic, there are options you can talk to your county sanitarian or county health department about.
Okay, thanks, Pete. So that is the last question as they have been submitted. So we will go ahead and begin to wrap up here. Let me begin by again thanking Dr. Peter Weyer and Ann Robinson on behalf of the Iowa Public Health Association for sharing their time and expertise with us today. I would also remind all participants that this webinar will be archived along with the presenter slides on the IPHA website. Please look for an announcement soon of additional resources on water quality and public health, which will also be posted to the IPHA website. As was referenced, there will be content related to this at the Governor's Conference. However, we ask that you also please save the date for a half-day conference on Iowa's water quality and public health that is being planned by IPHA from Monday, April 10th, just adjacent to the 2017 Iowa Governor's Conference on Public Health here in Central Iowa. Finally, I invite each individual attendee to please participate in the very brief, I promise, evaluation that will pop up as you exit this webinar today. We want your feedback on today's session and your input on subsequent IPH education and advocacy related to the breadth of water quality issues facing Iowa. Again, we thank you for spending this time with IPHA today. If you're an IPHA member, thank you for your investment in our collective work and mission. And if you are not yet an IPHA member, we invite you to join us today and take advantage of the 10% discount on dues provided to you as part of your registration fee for today's webinar. We need you to join us to build the shared value for public health in Iowa and in our nation. Thank you and have a good day.